Kia ora, here's question 2D from the Level 2 Algebra exam for 2025. So we have to solve an equation with logs. So the first thing that I'm going to look at when I see a log equation is I'm going to check what restrictions we have on our variable. So in here we've got 2 log to base 5 of x plus 6 minus the log to base 5 of x. And that means that right at the start we know that we must have x plus 6 has to be strictly positive, which means that x has to be greater than negative 6, and x has to be positive. So the tighter constraints one here, and that means that when I finish the problem off, actually that's not right, the tighter of those two is actually that x must be positive. Okay, so when we get to the end, when we think we've solved it, we need to come back and check that our solutions actually work in the equation. And you'll see that again next year in level 3, lots, especially when you're working with surds. Okay, so let's start by using our log rules to put some things back together. So if we start with just having a look at the whole thing, it's good that we've got the log to base 5, and we don't have different log bases. That would be weird and tricky. I've moved this 2 to the right hand side by adding it to both sides, and now I'm going to simplify this one first. So it's fine if you did this and you went faster than this in combined steps, but I'm just going to do one thing at a time. So we've cleaned this up. I'm going to leave this here as 2 for now, and now I'm going to simplify the left hand side and write it as this. So the rule that I'm using here is that the log of A over B is equal to the log of A minus the log of B. Okay, there are a couple of ways to do the next bit. But if we think about what a log is, if I have the log to base 2 of x equals 3, I can rewrite this as follows. I can rewrite that as 2 cubed is equal to x. So that's a really simple example of how we work with logs, which I call doing the loopy thing. And we can do that here. So here we're going to have, oops, when we get it back, we're going to have, what do we have here? 5 to the power of 2 is equal to x plus 6 squared divided by x. And from here what we're working with is a pretty simple quadratic. We're going to have 25x is equal to x squared plus 12x plus 36. That gives us 0 is equal to x squared minus 13x plus 36. And we can factorize that easily. It's x minus 4 times x minus 9. So that's giving me two values. X is equal to 4 or x is equal to 9. Now if we go back to the start, remember that our restriction was that we had to have x being both of these things. So x had to be positive. So it looks like they should both work, but I'm going to check them back in the original equation and just see what happens. So the original equation was 2 log to base 5 of x plus 6 minus the log to base 5 of x minus 2 has to equal 0. So let's substitute in and see what we get. Well, we get 2 log to base 5 of 10 minus the log to base 5 of 4. And if we clean that up, get the log to base 5 of 100 minus the log to base 5 of 4 minus 2. Combining these, we get the log to base 5 of 25, take away 2. 5 to the power of what is 25? 5 to the power of 2. So that equals 0. So that works fine. And we can do the same thing on x equals 9. We can do something similar and we can check that that one works as well. Okay, thanks for watching. I'll be back soon with question 2e.